Hello students. In this video, I will demonstrate how to solve a problem related to decision analysis. This is chapter number 13. And the first thing is what is decision analysis? Well, it is a quantitative technique that will help us find out the best possible decision when we are faced with many decision alternatives, and each decision alternative have some unknown future chance events. So you have to consider all the risk involved which each decision alternative and all the decision alternatives, and come up with the best possible decision. So here we're gonna do problem number 21 on page number 594. A real estate investor has the opportunity to purchase land currently zoned residential. So this is the payoff table given here. So this investor has two options right now: purchase land or not to purchase land. So he is hoping that the land will be rezoned to commercial land and he'll make some profit. So if the rezoning to commercial land is approved, he will make $600,000. If the rezoning to commercial land is not approved, he is going to lose $200,000. So the probability that rezoning will be approved is 50%, and it will not be approved is 50% also. So this is called a payoff table. The numbers here are the profits. So this is the maximization problem. We are trying to maximize the profit. Had it been cost, then your objective would have been to minimize the cost. So just keep that thing in your mind. Secondly, here if you do not purchase the land, there are no payoffs, and that's logical. That's why you have zero here. But it may not be zeros always. Okay, it may not be 50% probability for both the chance event. It could be maybe, for example, 75% here, 25% here. That's quite possible. So keep that in mind. So let's, with this information, so again the investor is trying to find out the best possible decision, uh, given that there are unknown events, that those events are rezoning probability. It could be rezoned to commercial land, or it may not be rezoned to commercial land, the property. Okay, so if the so let's answer number A. If the probability that the reasoning will be approved is 50% or 0.5, what decision is recommended and what is the expected profit? So when it comes to decision analysis, we always talk in terms of expected value. Okay, and this is how you find out the expected value. First thing first, we need to draw the decision tree, and this is how you would draw the decision tree. The square block that you see here, they are the decision node. So here you're going to make decision whether to purchase the land, which is D1, or not to purchase the land, which is decision D2. So you're going to follow one of the two decisions, and then each decision has some unknown chance events. So probability of rezoning, which is S1, is 50%, and probability of not getting rezoned to commercial land is given by S2, which also equals to 50%. And towards the end of the decision tree, you have leaves. So these are the payoff values from the table here. Okay, so how many leaves you're gonna have? As many leaves as you have here number of cells. Okay, so here we have 4 payoff values listed here. So given this information, this is just a representation of the same table here, so we are not doing anything new here. Okay, so if you decide to buy the land and if the rezoning is approved, investor is going to make $600,000. If the investor buys the land and the rezoning is not approved, then he's going to lose $200,000. If the investor does not buy the land, then the payoffs are zero, because he's not investing, and hence he's not going to make any profit. So given this diagram here, how can I find the optimal strategy for the investor? So this is what we need to do here. So we need to find the expected value for every node here. Okay, so let's see the expected value of 2 here. So how would you find the expected value of 2 here? It will be given by P of value, which is 600, times the chance event, which is S1, which is 0.5. So it's going to be 600 times 0.5, plus minus 200 times 0.5. So you have to consider both the chance events, okay? And that will give you the expected value of node 2 here. So it's given here 0.5 times 600 plus 0.5 times minus 200 here. And that should be equals to, we can do that calculation here. So just to speed up the calculation, I'm just gonna do copy and paste here. So that's gonna give me $200,000 here as a payoff, okay, for node 2. Okay, likewise we need to find the expected value of node 3, which is going to be 0 times 0.5 plus 0 times 0.5, which will equals to 0. Okay, so what we need to do here is we need to find the expected value of DC node 1 here, and that will be given by the maximum of the two alternatives. Okay, which one is going to generate more profit out of these two alternatives, we're gonna choose that one. Okay, so we know that the decision 2 is gonna produce zero payoff, right? So if the decision 1 is positive, then we're gonna go ahead and buy the line, because it's gonna generate profit, right? So we are expecting a profit of $200,000 if you go with decision 1. So here we're gonna do the max of all my expected payoffs here, and that's going to give me $200,000 here. So since $200,000 is a positive number, that means if I take a decision to buy the land, is gonna give me a profit. I'm expecting a profit of $200,000 here. So that's the expected value. Okay, so the decision is go ahead and buy the land. So expected value at node 1 is also known as expected value without sample information, okay, as this value is obtained without any additional market information. Okay, so yeah, expected value at node 1 is also known as expected value without sample information, which is $200,000 here. So I'm going to highlight my decision with a thick line here. So I'm going to say here, okay, I'm gonna go with different color here, increase the width, okay, and then I'm just gonna copy this format to everywhere. Okay, so I'm just gonna okay, so that's the decision I'm taking here. Why I'm taking this decision D1, which is go ahead and buy the land, because that generating expected payoff value of $200,000, which is more than zero value. Okay, so we're gonna make a profit basically if we go with this option. Had it been cost, then you would have considered the minimum value of the two decision and go with that one. That's something you have to keep in mind. Okay, so that's how you would answer part A. What decision is recommended? What is the expected profit? The expected profit is $200,000, and the decision is to go ahead and buy the land. Okay, now let's go to part B here. Okay, so part B says that this investor has an option to you know to buy some additional market information. So basically, he has to pay the money for this particular decision if he goes to buy the option to buy the land. So but this will give him more information about the market. So what do you mean by more information about the market? Well, let's say historically we have this information here. Probability that the resistance to rezoning is going to be high equals 55%. Probability that the resistance to rezoning will be low is 45%. And then you will be given these four conditional probabilities. So probability that uh, that the rezoning will be approved given high resistance is 18%. uh, Probability that here the rezoning will be approved given low resistance is 89%. probability that rezoning will not be approved given higher resistance is 82%, and probability that rezoning will not be approved given low resistance is 11%. And since it makes sense, right? So if the resistance is low, the the probability of rezoning may be higher. That's why it's 89%, right? Likewise, when the resistance to rezoning is high, then probability that the land will not be rezoned to commercial is going to be high also. So it's like 82% here. That's something you have to keep in mind. So given this additional information, what is the best optimal strategy? Okay, that's what we need to find out. So in this case, we need to see that whether the investor should buy the option to learn more about the market or not. Okay, so here he has the option to buy uh, the options basically to learn more about the market. Okay, so what we're going to do here is we need to this all information I have given to you, you can read it. It basically saying the same thing what I'm doing here in my lecture video, but this is how you would draw the diagram. I'm going to minimize this one so I can see it all. Okay, okay, hold on a minute. Okay, so let me hide the ribbon. Okay, I'm just gonna show the tabs here, so that's gonna give me more room. Yeah, this is better. Okay, so probably I can make it a little more big here and try to hide the. Okay, now this is much better, right? So this is how I would draw the decision tree. So let me go ahead and explain this decision tree. Okay, now the investor has option to buy option to learn more about the market. Okay, and if he did not purchase the option to know more about the market, then we know the expected value without sample information or without market information, which is $200,000. That's what we find out earlier here, right? So this is the value that we found out here, $200,000 is the expected value without sample information, okay, or without any information about the market. That is given. So if you did not buy the option, the expected value of the profit is $200,000. But what if he buys the option to learn more about the market? That will that increase his expected value of the profit? That's what we need to find out here. So if so, this is a decision alternative here, whether to buy the option or not. So if he buys the option, then there are chance events. The probability that there will be higher resistance to rezoning is 55%, and probability that there will be low resistance to rezoning is 45%. So these are the two chance event. For each chance event, we have two decision alternative: to purchase the land or not to purchase the land. So if you purchase the land, then probability that the rezoning will be approved given higher resistance, and that will be the payoff here 600, and this is the probability that rezoning will be uh, rejected given higher resistance, and it's going to be like -$200, -$200,000 here. So likewise here, probability of rezoning being approved given higher resistance is 18%. Payoff is 0 because investor is not buying the land in this decision alternative here. Likewise here is going to be 0 as well. So here I need to put in the value. So let's see, I can go ahead and so 0.18. Okay. Oh, it already had there. So let me undo this one. I should have just make it a little bigger. Okay, so this is how you would draw the diagram. Now what we need to do is we need to find the expected value at each node. Okay, and at each decision node we need to pick the maximum value. of all the chance events. Okay, so here at decision, like at node 4, we're gonna have expected value, we're gonna have expected value at 5, so we're gonna take the maximum expected value at 3. Likewise, we're gonna do the maximum expected value at 6, right? And then we're gonna consider this probabilities to find the expected value at 2. We know the expected value at 9, and at here we're gonna choose the maximum of the expected value at 2 and 9. Okay, so that's the overall view here. Now let's go ahead and calculate the expected value at node 4. So this will be given by 0.18 times 600 plus 0.82 times minus 200. Okay, and that will be equals to I've done the calculation here, so let me do it again. So this is the formula I'm using here. Again, I'm gonna do the shortcut here in the interest of time. So here I'm gonna say 0.18 times 600 plus 0.82 times minus 200. Okay, and that's going to give me minus $56,000. Okay, so that means there is an expected loss of minus $56,000 at node 4. Node 5 expected value is 0, right, because he's not buying the line. So the expected value at decision node 3 is going to be the maximum of expected value at 4 and expected value at 5. So here I'm going to say maximum of 56 minus 56 and 0. So that's 0. So the expected value of node 3 is 0, which is indicating that not to buy the line. If the resistance is high, don't buy the line. Okay, that's what it means. Okay, so likewise we need to find the expected value at 7 and 8. 7, it's going to be given by 0.89 times 600 plus 0.11 times minus 200. So that's how you're going to do it here. Okay, so 0.89 times 600 plus 0.11 times minus 200, which is 512. So I'm just again gonna do this, just copy this formula here. Okay, that should give me the same answer as, okay, let's fix this formula here. So we get $512,000 here at node 7. Okay, expected value at node 7. Expected value at node 8 is going to be 0 because the payoffs are 0. Okay, so expected value at node 6 is going to be the maximum expected value of the node 7 and 8. Okay, so that's going to be 512. So if you see the max of 512 and 0, that will give you the maximum P of 512. So now we have a maximum P of 512 here, okay, for node 7. Okay, that means if we choose not to buy the land, I mean, if let me rephrase that one. If the resistance to rezoning is low, then go ahead and buy the land. That's what it means. Okay, so but the the bigger question right now is, should we purchase the option or not? So we have calculated the expected value at 3, which is 0, and the expected value at 6, which is 512. So we can calculate the expected value at the chance event node 2, which will be given by 0.55 times 0 plus 0.45 times 512. Okay, so that's going to be here. So I'm just going to copy this formula here. So that should give me 230. Okay, 230.4. Okay, so the expected value at 2 after considering the market information is coming out to be 230.4 or $1,000. Okay, so expected value at node 2 is also known as expected value with sample information, which is given by expected value with sample information notation. Okay, because this information is obtained after taking into consideration the market information, right? So, and we have also already calculated the expected value without the sample information, which means expected value when the market information is not taken into consideration, and that came out to be $200,000. Okay, so what is the expected value at node 1? Well, it's going to be the maximum of expected value at node 2 and at node 9, and that will be the expected value at node 1, which is the maximum of expected value with sample information and without sample information, which is, so here I can do it here. uh, it is the maximum of sample information and without sample information, which was 200 here. Okay, so it's going to give you 230k. That, what does that mean? Well, that means that I'm going to choose this particular option to buy option to learn more about the market information. Okay, because expected value is higher here. It's higher by $30.4 thousand. Okay, that's pretty high. So I'm going to go ahead and highlight those cells. What I can do here is I can just copy the format here. Okay, let me show. Okay, that works for me. So I'm gonna go ahead and highlight this one. So if the resistance is high, okay, if the resistance is high, then we're not gonna buy. Not the entire thing. Not the entire thing. Okay, so let me highlight this one. So format shape, I'm gonna do the color here, and we're gonna increase the depth to 3.25. Okay, I guess that's what we had here, 2.75. So here also we're gonna do 2.75. Okay, and then I can format this one. Fortunately this should work. Yes, so this will be my decision here. Okay, decision 5. Okay, so no, I don't need to color this one here. So what I'm going to do here is, just to make sure I'm doing the right thing here. So it stops just here, decision 2, right? That decision 2 is like not to purchase land. If the resistance to rezoning is high. Okay, and now I'm going to go ahead and so if you purchase the option to learn more about the market information and resistance to rezoning is low, then I would rather go ahead and buy. Again, the same thing. So I'm just gonna do it individually here. Let's say 2.75, and I will copy the format to highlight this option. Okay, so what does this mean here? This means that investors should buy the option to learn more about the market, and after learning more about the market, if the resistance to rezoning by the area residents is low, go ahead and buy the land. If the resistance to rezoning is high, then don't buy the land. So uh, that will be our conclusion here. Okay, so that's what I have written here. So without the purchase of option, okay, that is the first one here. Without the purchase of the option, if you don't have and don't want to know anything more about the market, okay, then what should be your decision? Your decision is to purchase the land with the expected value of $200,000. Okay, so you have to see part A, right, above that I just showed you. If the decision is to purchase an option, then the best strategy is, uh, if the resistance is high, go with decision to do not purchase the land. If the resistance to rezoning is low, then purchase the land. Okay, so and if you went ahead with the purchase of option, then your expected profit is going to be $230,000 here. Okay, that's how you would interpret the results. So the part C is, if the option will cost investor an additional $10,000, should the investor purchase the option? Okay, so expected value without the option was $200,000. With the option was $230,400. Okay, or $230,400. Okay, with that additional information, you're making $30,400 more. So I would rather go ahead and pay $10,000 for the option. So after paying $10,000, I would still be making $20,400 as the profit. Okay, so since the option will cost only $10,000 and we are expecting to make 30,400 additional profit, expected profit, we would advise investor to go ahead and purchase the option. Okay, so here, so I guess this one will make it a little bigger here. Okay, so the maximum that the investor should be willing to pay for the option is $30,400. That's the maximum you would investor would pay, because after that he will start incurring the loss. Okay, so that's been asked in the question. So what's the maximum the investor should be willing to pay? Well, he should be willing to pay up to $30,400, because he won't be incurring any loss if not profit. Okay, but after that he's going to start incurring the loss. So this is how you would solve the decision analysis problem here. Thank you very much for watching this video.